Hello, everybody. Jim Hogan here. Welcome to Virtual DAC 2020. And this is different for everybody. And so I've been working with a few companies, getting a hold of the CEO and founders and talking about what they're going to do at DAC to give you an overview of what the company's about and then what they're going to be showing at DAC or virtually showing at DAC, and see if you have interest in that. So hopefully this will be an outline for you to consider visiting those sites. So at this moment, at this time, we got Rich. He's off to the right there on my screen. And Rich is CEO and founder of Semifore. And I think I want to start just, Rich, how did Semifore just come into being a company at all? How did you start this? And then, what problem were you trying to solve?
Okay, thanks, Jim. Basically, throughout my career, I've been responsible for system architecture. How does the system interact with the operating system? And so from like my very first experience right out of school, I was responsible for setting out the address map for a workstation and how the device drivers in Unix were going to interact with it. And I've done that sort of as an architecture person. I've done that for almost every system I've been involved with up until I started Semifore. And through those years, we discovered that the hardware-software interface was, I like to call it a point of contention in the R&D development path. I remember a time at Silicon Graphics where we were working on high-end graphics workstations and supercomputers that at least every Monday morning there would be a large brawl in the R&D department. But somebody changed a bit in one of the registers. All the regressions failed over the weekend, and that the documentation was now out of date with the RTL, and all the header files were wrong. And this happened every week for I guess 2 years, and it was pretty clear that
perfect. Other than that, it was perfect.
Yeah, yeah. Other than that was we had all sorts of other things going on, but at least this one point did cause a lot of churn in our project, and it was continuous. Every weekend, some RTL designer changed a bit, and it pissed everybody off on a 50-person project.
And I'm sure whoever made the change did it for good reasons, And
of course.
Sort of keeping it, yeah. And everybody, but it was just keeping everybody synced. Had to be a bitch, right? And that's why you had those contentious meetings. Yeah.
Right. And so that was, and there were several things going on at the same time. Is the RTL designers were a little lazy about keeping their documentation up to date. And certainly the registers are part of that. And I really can't explain why they didn't send out emails saying, hey, I just changed this bit. Please, everybody, catch up. But it's just the way things worked out. And my next step in the career was at a networking startup. And when I started architecting those devices, it was obvious to me that we had a whole bunch more registers than we did at Silicon Graphics, at least on the supercomputer. So networking is extremely hardware-software interface rich. The hardware and software, there's a high touch point there. And what does that mean? It means there was already a factor of 10 more registers in these little networking devices that we were designing compared to what was happening in the supercomputer world and with the I/O devices. And so in that particular startup, we decided to automate the hardware-software interface and the management of the RTL generation, generating the documents, generating the files for verification, and we also generated the files for the device driver development. And that particular company, we also generated stuff for the lab. So we automatically generated a lot of stuff there. And the reality
so you had like one big meta model, and you could derive all views and things you needed out of that. So that by nature created a synchronization capability, huh?
Right, and the hardware-software interface is such a large fraction of what networking chips are all about. That represented a huge part of our R&D effort. And having that automated meant that we were moving really fast, and were able to have a much smaller team than you would otherwise expect. And that was a good experience. I mean, the issue there was back then in the late 90s, you couldn't buy a tool to do this. And so we had to develop ourselves. And realistically, half the R&D team spent some time writing scripts. And I personally spent half of my life implementing that stuff. And so when you think about it, we had a chip project, and you could measure the effort in the automation for the registers in man years. Now, we were able to leverage that across several chip tape outs, so it wasn't so bad, but still it's measured in man years in a startup.
From a reuse point of view, you were able to reuse all that, I take it.
Well, right, we're using the framework that we had, the scripts and stuff. Yeah, we were able
the capability, the tool.
Right.
Yeah, gotcha.
Right.
Thanks.
And so within 18 months, we went from concept to taped out chip, and very quickly the whole company was bought by Cisco, and so we ended up inside of Cisco, and that was quite eye-opening. Now we were designing small networking widgets, and now we're inside of Cisco where they're very large networking widgets. And the CTO office at the time was very concerned about best practices
So some would say that you were also developing Huawei's networking products, but that's a different story.
That's definitely a different story. I have stories about that.
We'll catch that and edit.
Yeah, right. But so the CTO office was really concerned about best practices with ASIC design. At the time, Cisco was respinning every chip that they taped out 6 or 7 times, before actually worked for the customers, and that was a serious disaster, actually, financially and time to market wise. So they brought a quick
value prop check we'll add to this is that you're getting more productivity for sure, but you're also getting higher quality and shorter time to market. So
yeah,
3 big value props. Yep.
Right. So the CTO office was having these meetings with all these newly acquired startups, the chip startups they had just bought, to see across that whole portfolio what people were doing that made a lot of sense and that they could roll out across the company. And I championed this concept of, networking chips have this huge hardware-software interface, and this is absolutely something that needs to be automated. I mean, at Cisco, no, you can't tape out a chip without this. It's impossible. There's just too many registers. People can't deal with it. And I like the analogy is, back in the day, you'd sit there with your Ruby lith and you'd put down every transistor. No, nobody does that anymore. There's just too many transistors. And likewise, the hardware-software interface for some chips is approaching, impossible to be done manually, right? And so I championed the concept of at the time. It turns out a lot of the startups had something. Everybody had some scripts to do this, and the issue was we wanted to roll this out across the whole company, and that would provide a lot of things. As far as efficiency,
I think it's probably worthwhile to remind the audience that at that time Cisco was buying a company a week, kind of thing.
Yeah. So there were several fabless semiconductor networking startups that they had purchased. Some cases they wanted the technology. In other cases, they wanted the design team that knew how to do chips. Because, like I said, they were in a situation where they were respinning 6 or 7 times on every device, and that was a bad situation. And so they knew that they had to do things better. Chips are not little boards, and that was sort of the background. Cisco was a board design company that transitioned to doing ASICs, and I think they made a lot of missteps in the late 90s, basically thinking chips are little boards. So the effort with the CTO office went forward. There was actually a project funded. We staffed up software engineers to go and develop a tool. And Cisco eventually spun that out as Denali, as Denali Blueprint. And Cisco really didn't want to be an EDA company, so they farmed out. I mean, like, there was a staff of people working on this project internally in Cisco, and they thought, well, we should just outsource that. We're not an EDA company. And so that's how Denali Blueprint was created. And through that whole process, that took about 5 years, I was involved with that. And so you could probably blame me for a third of what System RDL is today. And so and part of what Cisco wanted is that the internal language for specifying the registers to be standardized, and that became System RDL.
Yeah, well, no good deed goes unpunished, my friend.
Right. And so the Denali found a home at the Spirit Consortium for System RDL. And around that same time, I was personally feeling that Cisco wasn't the right place for me anymore for lots of reasons. And I was sort of thinking about what to do next. And after having been through a couple of fabless semi-startups, I thought, well, it'd be really cool if we had, there's a lot of things you need to get a chip done. And some of those things you can't buy from anybody. You have to make them. And that's always a time drag and a resource drag in any startup. You're burning through precious time and money developing infrastructure at a fabulous semi-startup that, if you could just get that stuff, you could hit the ground running and be more productive. And so I had this fantasy of fabulous semiconductor startup toolkit or toolbox, the stuff you need to do a chip that you can't buy from the big EDA companies. And the first idea I had is, all right, well, this hardware-software interface thing was really bad in the sense that we really needed it at Cisco to do any chip. And so, well, eventually everybody in the industry is going to have this problem, that the register count is not going to get smaller, it's going to get bigger. And so I said, all right, I got a couple of buddies of mine, and we started Semifore. And we started in January 2006. And we typed really fast, and so we had a working something at DAC 2006, and that was totally awesome. So that's how I got from part of my career to getting Semifore up and running.
So Semifore's really been around for about 14 years then.
Yes.
15 years. Okay.
Yeah. So DAC 2006, we had working product ready to ship to the customers, and here we are. A DAC so many years later, talking about it again.
So here you are 14 years after the fact, right? And so you've learned a lot during those 14 years, I'm sure, a lot of customer interaction. What are customers telling you they need now?
Well, some of the things that our customers are telling us today are things they need. Realistically, they need more help in moving the register information into the device driver and working with the C world. I guess the situation, I characterize it this way. In the verification world, the System Verilog folks have actually done a very good job at standardizing register modeling with the UVM register abstraction layer. And I know a lot of people have opinions one way or the other about that register abstraction layer, but the mere fact that it exists is a big deal in being able to support our customers across the board with the modeling for verification. Unfortunately, in the C world, it's more of a Wild West. Every company has their own class libraries that they use to model registers. And that's an area I think the whole industry has to look at is there some way we can find consistency across the industry so that we could have some standardization in that area. And realistically today, Semifore is providing our customers with assistance on their own custom C library situation. But I think everybody would benefit by having a standardized sort of HSI, hardware-software interface definition or modeling for the C world. And once that exists...
Or everybody could just buy Semifore.
Yeah, exactly. and certainly once that we have that agreement to work with a standard set of libraries, let's say, then the Semifore tools will natively generate that, and then the whole industry would just have access to that immediately. And that's certainly one area I feel that is sort of a lacking as compared to other areas in the hardware-software interface.
Well, when you walk into a customer, they must have inputs in a very heterogeneous way, right? They must have inputs from everything. So as inputs to the Semifore environment, you got to deal with a lot of different things, don't you?
Oh yeah, that's a good point. Thanks, Jim. Realistically, the register, I talked about system RDL as being a standard.
Yeah.
But realistically, that particular standard is quite dated now and is showing its age with a lack of capabilities. And so our customers are doing very diverse things. The folks with the smaller devices are still back in the days when they're doing everything with spreadsheets. Register specifications look like tables, spreadsheets look like tables. It seemed like an obvious thing. But spreadsheets themselves, after a certain register count themselves, get not difficult to work with, let's say. And there's a lot of optimizations you can do in your process that the software world uses for their C code that you don't really have access to in a spreadsheet. And so one thing that we do is, certainly the CSR compiler can read the spreadsheets. We support several different spreadsheet formats for the folks that have that legacy or are used to doing that way, and realistically, there's a lot of analog designers that really don't want to go any further than a spreadsheet, but their designs are small. Then I talked about system RDL, and the use of system RDL in the industry is, as far as we can tell, is decreasing. But there's still a lot of legacy or heritage code out there, depending on how old it is, that needs to be continue to move forward with new designs. And there's another standard that I've been involved with called IP-XACT, where the concept is you package let's say you're a third party or internal IP provider, and you need to distribute your IP to the folks that are going to use it in their design, and you package it with IP-XACT metadata, and part of that metadata is the hardware-software interface. And so those sort of an example of the diverse set of inputs that the CSR compiler works with. And so the CSR compiler has been architected to be able to read those all in on those different formats in at the command line at the same time. And so in that regard, the CSR compiler is a linker of different file formats. And likewise, the CSR compiler can output all the input formats. And so if you've decided that you get an IP-XACT file, and unfortunately, there's still a lot of trouble in the IP-XACT world as far as accuracy of those files. So maybe you need to fix it, but you don't want to edit the XML, so you translate it to something like CSR spec, use your editor and make the adjustments to get your project out. Or you want to rescue your system RDL and convert it to a more modern format. So that the CSR compiler is also a cross compiler. It can convert one format to the other, and our customers find that very valuable to do all those things.
Yeah, I could see where they would, right? It's kind of like a Star Trek, and you can go anywhere in the universe and everybody speaks English kind of thing.
Yes.
That's amazing how that works. So that's got to be tremendously valuable in a number of ways, right? As we already said, you get the productivity right away by automating. Secondly, you get the quality because compiler always converges, right? Third thing is you can deal with all your legacy code and translation all with the cross compiler. So those are all really pretty good value props, right?
Yeah.
How are you doing? I know a little bit about the background of the company, and I know in the last couple of years, you've really expanded your client list as people have looked at the current product and their needs, right? So you got customers that are building cars to guys doing IoT chips, don't you? Tell me a little about your customers.
Yeah, so the customer base has been quite diverse. Certainly, early on, we were very, I guess, top heavy in the networking world. Like I said, networking chips
Hmm.
have a very large hardware-software interface, and so we had a lot
And,
of
and that was your legacy, so that makes perfect sense.
yeah,
Yeah.
exactly. But yeah, so the we had a lot of connections with those kind of customers and a
Yeah.
lot of uptake, both in smaller networking companies that were finding that they needed automation and they just didn't have the staff or the funding
Yeah.
to do this kind of tool development internally, or whatever tool they had. The story was often, well, the guy left and now nobody knows how it works, and so they were looking to us to help them with that situation. And then, of course, fabulous startups in the networking space, they wanted to hit the ground running, and that was very exciting for me because I got to meet all the startups that way. So that
Hmm.
was good. And certainly, we had some in medical devices. There was some uptake in the early on, and aerospace also was very interested. One thing that our tool also do, not only do we generate RTL and system Verilog and Verilog, but we also generate the RTL and VHDL, and we also provide
Wow.
verification collateral in VHDL. And a lot of the aerospace industry is, or especially in Europe, is still
Hmm.
using that. And so those customers were very enthusiastic that people were still doing VHDL support. So
Wow.
those were early customers for us in the aerospace world. Um,
Wow.
yeah,
Well,
and
I
so
mean, it's amazing customer portfolio was
right,
assembled, right?
right. Yeah, we're
Wow, that's
very
crazy.
happy. I mean, I guess I should mention another part of another industry that's very heavy in the hardware software interface is graphics. Graphics
Hmm.
chips. I mean, I used to work at Silicon Graphics. I mean, there was a whole department of people that developed the hardware software interface for the SGI graphics engines.
Hmm.
And and in reality, at the same time, the supercomputer division was having these arguments every morning about the bits don't match. The graphics team had automation in the register space. They already needed it in the mid '90s because of the size of their hardware software interface. Um,
Yeah, I don't, all problems come back to being a problem, right?
yeah,
It's just this, but they generally don't get to be any smaller problem. They're always a bigger problem. So you
yes.
probably had to grow in complexity and scalability too, didn't you?
Oh yeah, so that was definitely as far as complexity goes. One of our early customers, I guess I'll mention it because there's a paper out. They published a paper at DAC a couple of years ago. Is Microsoft. Microsoft was making devices with very large register counts, and they were looking to us to support them in that. And so let's be realistic. If you have a device with 300,000 registers, let's say each one's 64 bits wide, that's a lot of information. And then I've sort of surveyed my customers over the years, and there's an interesting statistic I have is that the average register has 5 fields. And so the field is actually the atom of complexity. So 300,000 registers is 1.5 million fields. And so if you think about a Microsoft device with 1.5 million fields, and you think, how many registers is that per engineer? And you say, well, gosh, each engineer has 30,000 to 50,000 registers to specify, implement, document, and it has to be verified, right? And so, and the whole project needs to be in sync. And of course, a company like Microsoft on these devices has a very large team across, multiple physical locations. And so there was a couple of things that are important. First of all, the tool has to be able to handle a design that size with 1.5 million objects.
Yeah, the
And the
data
other thing,
structure itself.
oh
Yeah.
yeah,
Yeah.
it's a lot of information, and it fills up memory pretty quick as far as a tool running. And then the next issue is, well, how long does it take to run? So every time, with 1.5 million fields, how many fields are changing every day on that project? And how many times a day do you need to regenerate all the collateral for all the team members in verification and software development and RTL design. Every day they need to be synchronized multiple times a day. And so another aspect of the CSR compiler is that we also focused on, well, it has to run within seconds, really. And for the vast majority of designs. Now, realistically, if you've got a couple thousand registers, yeah, your runtime is within seconds. Now, if you got a million, now the paper that Microsoft published several years ago, that 300,000 was a big number back then. But nowadays, we have customers with 5 million registers, and you think about, well, that's 25 million fields, and what's the runtime that they need on a project like that to rerun the tool. And we of course have been working with our customers, and we have information about the usage of the tool, and we know customers run the tool 3,000 to 5,000 times a day to make sure they're in sync with everybody, because the bits are continuously changing and everybody needs to have the up-to-date information. And so those two aspects are very important. First of all, to be able to consume the largest designs, and to be able to process those kinds of designs such that the design team can do multiple turns on the design a day. Yeah,
I mean, it makes perfect sense. I mean, it's great if you can keep track of everything, but not too useful. It takes a week to compile.
Yeah, right? No. I mean, if it takes more than a minute or two to compile, then all of a sudden, just this automation is becoming a bottleneck in your flow. So you want to get that out of the way.
Yeah, for a guy like me, 2 or 3 seconds, I lose interest. So
exactly.
I know you got to be doing some tricks on incremental stuff just to make it faster and whatnot, but that scale is hard to deal with on a continuous basis. It's not going to get any less.
No, it's I mean, that's something that we have to profile our tool and see if there's areas of improvement continuously. I guess that's another thing I want to talk about in this particular industry, is that we're not done yet. This is a moving target. It's, System Verilog has been published and standardized for years now, but the hardware-software interface and the formats that are used there are still in the infancy stage, and are changing a lot over time.
Well, I get that question all the time, right? When are you going to retire? And I got to remind people I'm not dead yet, right? So I totally understand. Rust never sleeps. It just keeps on going, huh?
Yeah, exactly.
Keeps on going.
Yeah. Right? So the designs are getting larger and more, and we need to support more sophisticated features as time goes on.
I'm just trying to keep an eye on the clock too. So, we promised these guys about 20 minutes. I think we're a little further than that. So here we are. Thanks, Rich. That was great background. What's going on at DAC this year? What do you want people to know about Semifore, and what would you like them to see at your virtual booth?
Well, certainly we've been working pretty hard for this year's DAC. We've updated our website, where we're definitely giving people more collateral so they can better understand what our product is and the features that we offer. We've got a couple of videos coming in that will, in a short amount of time.
Not as good as this video. Not as good as this video.
Yeah, this one is probably much more interactive than the other ones. But yeah, so that's what we're doing is basically showing people more about what we're doing. And of course, there's some new features, but like I said, over the 14 years, it's been incrementally every year. We've got new things to do, and that we continue to do that. And we'll be showing that stuff off. And it just we're continuously adding features, so we definitely have some stuff to show this year.
Well, so people, they go to the virtual portal, check it out, and it's great, but it's not all that interactive. So if they have interest, how are you handling that?
Well, the virtual DAC does have provision during the DAC virtual hours to actually contact and have a meeting with somebody from Semifore, and you can have a longer conversation. usually how this progresses is that we have the conversation, and the very first thing you want to do is take the Semifore CSR compiler home and try it out on your own designs. And we definitely look forward to having those conversations and moving to that next step.
And certainly if it doesn't fit in the DAC window, you'll have time to talk to them anyway, right?
Oh yeah, absolutely. It's certainly during the DAC time, we can answer questions, if people are interested, maybe show them a very short example on how the tool works. Mm-hmm. But realistically, when we're talking about thousands of registers and complex features that people have in their designs, they want to see it in their own shop. And certainly we can show you that we can handle that stuff in the conversations that we have through the virtual DAC. But
well, everybody wants to drive the car, right?
That's
before they buy, kind of thing, right?
Yes, exactly.
So look, I think what you've done over the course of your 14 years in the commercial side of this is come up with great product, give people a lot of productivity, ensure good quality, and manage their designs. That's something everybody ought to take a look at, I think. And in all probability, at least what I've seen with the company is over the last couple of years, actually, is that increasingly a lot of diverse companies are utilizing the tool. So I'd recommend everybody come see you and spend some time looking at what you have, right? So anyway, Rich, I want to thank you for taking the time today, and for the audience, please take advantage of the opportunity to look at Semifore. And also, if you have questions beyond DAC, Semifore folks are willing and capable of ensuring that you get your questions answered in a more in-depth conversation. So thanks a lot for joining us this morning. I guess it's not this morning out in virtual land, but thanks a lot for joining us with the conversation. And Rich, you've done a great job. Thanks for sticking at it. It wasn't an easy job. I appreciate that. And You've really created something that the industry can really value. Well, thanks a lot, everybody. Thanks for joining us.
Thanks, Jim, for taking the time today and have the conversation.
You're welcome. I learned a lot from it.
Okay, thanks.